Hello everybody, I hope that you can see and hear me. Yesterday we had some slight issues with the connection. I hope that today it's going to be much better. Today I will talk about Cloud native serverless access control, and this is a topic which is very interesting for us because this is something that's very new for the enterprise environment and for using cloud native applications and cloud in the enterprise. So when we were trying this project, when we were thinking about this application, then we had a problem statement. And this problem statement was that we need something in the enterprise and the thing is that in enterprise applications, we need access control. And there is access control in the enterprise applications right now. But it's very important to understand that it's very important how we do it and that we have to do it right. Because enterprise applications are not play fields. Because I've learned it because I was working in an enterprise environment, we were developing, and we were doing something silly, not really correct, but it was not very serious, but still. The next email that was coming in German was that the production system ist kein Spielplatz. It sounds very harsh in German. So it's not playfield. And access is not like in other applications where you can access things and then it's not a problem. If everybody can access everything, then it's okay, then you can work with it. In the enterprise application, the access should be based on the need to know basis. So you shouldn't have access to things that you don't need to perform your own task. The applications and even enterprise applications move to the cloud. And when we are moving applications to the cloud, then we don't like to develop applications. We like to use services instead of the application, instead of developing an application. It's good if we have everything ready and we only need to configure and we don't have to write things. So this all came to a conclusion that we need access control because it's not a playfield. Access is very much controlled. Things move to the cloud, so we need an access control and it has to be a service. So in this presentation, I will talk about what we have right now in the enterprises, what we aim, a kind of architectural structure. Then I will talk a little bit about the project structure of the development and the governance of the project and about what we have already delivered and about the roadmap and vision. And finally, I will give a short summary. So what do we have now in enterprises? In enterprises and enterprise architecture today, we have authentication and, well, we have it almost everywhere. It's already central. There are standard applications that you can use to log into a system. So authentication is solved, kind of. Authorization is role-based access control. So usually when somebody is using the system as a kind of administrator, like a client advisor or a bookkeeper, then they have some kind of role based on their role in the enterprise. And then there is some role assigned to them in the system. And based on this role that the person has in the application, they can do several things in the application. And the application checks that the current user is a bookkeeper, the current user is a client advisor, the current user is this or that. And based on that, it performs or doesn't perform the requested action. But the record level access, so when I'm accessing a certain specific record, is usually hardwired into the application code. Like, for example, when there is a group of client advisors, then the client advisor group leader, or the boss who is the leader in that group, may see all the records that belong to other client advisors in that group, but not from other groups. And these things are hardwired into the application. So the application has to know this arrangement between the people, and also has to know the arrangement between the records and the group. What we aim is to change this a little bit and make it more flexible. What we want to get is a centralized access management, an access control service, which is managing and storing policies. Policies define who can do what. And to do that, we realized that we can separate, and we have to separate the logic that tells us who can do what, and the enforcement. The enforcement is the guard, and the logic, we call it the advocate. The advocate tells what you are allowed to do, but it cannot force you not to do that. It's the guard, which is part of the business application, that either lets you do it or sends you away if you don't have the right to do it. And this policy-based record-level access control service, what we have here as actors or major objects is the user, the action, and a resource. Who can do what on that resource? A policy is usually assigned to a resource. So it's very important to understand that when we have some kind of access control, for example, in a file system, then every file has an access control on it. But in an enterprise application, it would not be good. It's much better if we separate the records and the policies, the access control description, and the resource has a policy assigned to it, one single policy. And this policy is kind of security type or access type of that resource. For example, if I have documents, then I can classify these documents as legal documents or a manual or marketing flyers or some personal. And then based on this, there are policies, one for the legal documents, one for the manuals, and so on. And the policy describes what can be done by whom. So there are authorities like users and roles or groups. And then if somebody is part of the legal department, so member of the legal group, then they can do different things with a legal document than others who are not. And the effective policy is a calculated action list or action set, which is valid currently for the current user. So if I have a specific user and I say that I want this policy, what is the effective policy that controls my access to the record, which is controlled by this policy, then I will get back the actions, what I can do with this certain record. The action itself is something the application can perform. The interesting thing is that the access control advocate who is calculating this list of actions, it doesn't know what a certain action is. It's a string. It's totally opaque for it. It doesn't know what it is. So for example, if I define a door, for example, an internet IoT device door. So there are really real actions for a door, like opening a door, closing a door, locking, unlocking. Then open is an action. The advocate and the access control system doesn't know what it really is when you open a door, that the air can go through it or you can go through it, whatever. There are many physical consequences, but they don't care about it. There is a user who is trying to access. So when we are asking the advocate, then we say that we need to know whether this specific user is allowed to open something for which the policy is named storage room doors. And then the access control guard is what will enforce what the advocate says. So the guard doesn't know what is allowed, but it can send you away if it decides. I mean, it doesn't decide, it just decides based on the advocate. It asks the advocate, and then the advocate can calculate the effective policy, but advocate itself is powerless. The guard asks the advocate and sends a request and gets an advice from it. So this way, if we separate the concerns, then we have the access control advocate, which is talking to the persistence layer, which stores the policies. And then when we have a business application UI, which is communicating with the business backend or presentation service, then first of all, it is communicating with a guard. And the business backend itself, which can be totally separated as a service, a separate service from the access control guard, or it can be integrated together with the access control guard. It's if the guard and the business backend is not so complex, but logically they are separate modules. Then the business backend just serves every request. If somebody is asking something to do, it will do. It doesn't care about access control. It has to be configured the way that only the guard can access the business backend. And then the guard itself will understand the request, will understand who the user is. It should understand what groups this user is inside, what role the user has to ask the access control advocate about the actual action. And then it has to go on and ask the business backend the same question that it was getting. So it passes on the question and then passes on the answer. Or it may say that, no, you don't have the right, go away, and sends back a 403 or whatever HTTP code it sends back if it's a REST implementation. The access control request is containing the group memberships, some roles that the user may have and the certain actions that we are interested in. And it's interesting to understand that the access control system doesn't really care about group membership because it's not their concern. Different applications may manage different group membership databases. And it doesn't really care about the roles, especially because it cannot administer the roles, because roles are things like owner. And when I have a document or any business object that has an owner, then this information that who is the owner is usually stored in some way, in some database table, in some field inside the object somewhere. And then the guard itself can read this information, can check that the current user is the one who is the owner, and then it sends the request to the access control advocate that here is my request, this is the user, member of these groups, and by the way, he has the role that for the object which is concerned and controlled by this policy. You don't care which object it is, I just tell you the policy. Just this information is that for the object that I am handling, this user is the owner. Or it may have different other roles as well, not just owner. Owner is the most frequent and it exists for a long, long time. And in many times, owner exists in our business applications. But if I think about a task, then I can imagine roles that somebody is passing on a task to somebody else, then he may be not only the owner of the task, but he can be responsible for the task, or he can be a controller of a task, or other different types of roles. The sample application that we were imagining is that because we wanted to implement this, and obviously not only just imagine an architecture and then dream about it, we wanted to have a business application which is controlled by a guard and the access control advocate. And then we were thinking about that, okay, we need some application, what can it be? And we realized that if we want to manage the policies, then we need a management application which manages the policies. So that you have a user interface, UI with React and nice and beautiful, and then you can log in and then you can create some policies, you can delete policies, you can do all sorts of things. And you can do it only if you are authorized to do that. Therefore, the access control card of the management backend, the access control management backend is actually the sample application. And we implemented the policies as access control lists. And it's very well established. It's nothing new. Access control lists exist for a long, long time. And it can be used to apply for group memberships, user ID roles, and it fits all the needs that most of the applications have. And actually, an access control list is nothing else than a collection of access control elements, so ACEs, and every ACE has an ID, so a kind of authority ID, so it can be a group name or a role name or a user ID, and a set of actions that what this authority can do. And when we calculate the effective ACL, that's nothing else than a set of actions, and an action gets into this effective set if the action is member of any of the ACE sets where the role is either the user itself, the ID is a role, the ID is the user itself, the ID is a role which the user has currently, or the ID is a group ID that the user is member of. Now, how we developed it and what we really did. So a project needs developers, very obvious. And this is not a client project, so we don't have much financing. Mainly we are doing it for enthusiasts and from extra time. But this is a little bit more, it's not a hobby project either. So it's not like, let's do it on GitHub as an open source something in our free time. It's EPAM project. At the same time, we started the West European Junior Project mentoring development. And in this project, we hire juniors who go on a mentored educational program, which was originally established in Hungary, but it's applied for Switzerland in a little bit different way. It approximately takes 6 to 9 months, but the juniors are on a bench project and learn only for 3 months, and after that they start to work for a client for a special financing, and then later on they become full-blown juniors and members of EPAM. And we need some project for them to develop, which is meaningful. And it's a kind of win-win situation, because we were thinking that this is really something interesting for them. It's a greenfield project, they may like it. And we get the resource people who will work and develop it. And it turned out that they really liked it a lot. So the project structure is that we have currently 3 junior developers, or at this moment only 2, because one of them already works on a client project. It was positioned very soon. We have senior developers, and it's very interesting that, for example, Yegor was on a bench and was assigned to this project, and he helped us a lot. And then he went on a client project, but from time to time he still does some work with us because he's so enthusiastic. Attila joined us recently. He is on a project, but he said that, no, I want to work on this. I like it so much. the idea. And also Csaba is working with us because right now he's in part-time working, and he needed a project where he can ramp up again after some leave. And I'm the project lead and lead architect who designed the whole thing. And we are using EPAM resources, GitHub, Jira, Confluence. We have 2-week sprints. We have already delivered a proof of concept application. We are aiming for an MVP in a few weeks, and we have a clear roadmap that I will talk about. And let's see what we have delivered already. The POC was delivered in September. The MVP date is approximately in a few days. We have a defined roadmap where we want to go on. We have this presentation. We have some technical documentation. We have a white paper. We are working with Java 15, Spring Boot, MongoDB, and React. And we have CNSAC, that stands for Cloud Native Serverless Access Control. And we have the Access Control Advocate, the ACA. We have ACG REST, persistence, and so on. So there are many, many modules in our application. The proof of concept was minimal management UI that we can work with, the advocate. We had a guard. We had general ACLs without ACL type. And we had hardwired users groups and one single role owner. And these were hardwired for the application. And for the minimal valuable product, we are aiming to have the management UI with group management, so that we can manage the groups which are relevant for our own management application. It's very important to understand that even though we have a group management, this group management is not for the general business applications. It's for the access control management application, which is itself a business application. We have the advocate, we have our own guard, we have generally ACLs, we have negative ACLs. Negative ACLs are the thing that when you have an ACE and it says a SAT, and what are the rows that are allowed, then we make a union of these sets which are relevant for the current user. But we can have not only permissive but prohibitive ACEs that says that, for example, the owner cannot do this and that. For example, we have a group of people who can approve a certain document, but they also create documents. Then being member of the approval group is not enough if I own the document, because I'm not allowed to approve my own document. We also have ACL types, because there is no reason to assign an ACL to a document which ACL lists all the actions which are relevant for a door, for example. You will see that the guard will get the list or set of the actions that you can open this document. Open, maybe they understand what open is. You can lock it, unlock it, close it. What does it mean? It's not really it's not for a document really. It's a different thing. So an ACL type actually is nothing else than the list of the actions that are valid for that special object type, or ACL type. Also, ACL type is referencing controlling ACL, because if you want to edit, modify a type, add a new action to it, or whatever you want to do with it during the through the management interface, then proof of the pudding is eating it. It is controlled by an access control list itself. Here is the user interface. We can see that this sample is listing all the ACL types. So what we have right now in the application as a demo, We have types that facility, door. We have different ACLs, which is called facility, and the type is meta. So it means that it controls ACLs. Door is a security burial. A host file, which is a CRUD type, so it says create, read, update, delete are the actions for it, and so on. We can also list the ACL types, which you could see on the second column in the previous slide. Meta and CRUD and security barrier which are currently in the database when this screenshot was created. Then you can add an authority type, so you can add groups or you can add users or roles into an ACL when you create a new ACE. So you create an ACL and you add access control elements to it, and the access control element has an authority type, and then you can add different actions to the same access control element. In this case, if the type is CRUD, then you can add create, delete, read, and update, but not door opening or locking. Okay, this is very interesting, but the more interesting and the thing is that makes it very thrilling is the roadmap and the vision. Because what we envision with this one is that we can go forward and we can have this application and we can have it used and being implemented in some application which is using it for access control. So in the roadmap, we have some features they envisioned, like ACL inheritance and approval workflow, for example, changing the different access control lists, or not just storing the ACLs in one large database table, but much rather storing them in some kind of folder structure. So you can delegate the work and you can organize them. It's just a very short list out of the roadmap features. But generally, the most important thing in the roadmap is the business agnostic business service. And really, this is the vision, because with this access control, it's general. It can be applicable to almost any application, and it gives an enormous flexibility on the access control part of the security. And if we do this, then it makes it possible to create applications which are not strongly tied to the actual business functionalities. What I envision is that a general calendar application or a general workflow application that works with some kind of document. And then when I want to have a business application which uses some calendar features, which uses some workflow features or approval workflow features, or uses some resource management features, or uses some scheduling features, then I collect these services, I configure them in the cloud, but these are the only services, general services. And then I can develop a JavaScript UI which uses these services. And if these services already use the access control service, and I can configure the access control independently from our application really, then I can develop not all, but many applications only creating browser JavaScript. And everything else is only configuration and only services. And this is really thrilling because it means that for many applications, not all applications, but for many applications, the development will be pure JavaScript, pure browser on the client, and no server programming, only configuration. So I was cutting this presentation a little bit short because it's late and because we were starting a little bit late. What is the summary and the takeaway? We have a project. It's called EPM GPVE APAM Junior Program West Europe. It's in live. You can join it if you are interested in. Anyone is welcome. Kind of open source inside EPAM. Then if you are interested, it's not only, you can support us not only looking at the source code and modifying it and helping us to make it better or anything like that, but also you can use this application. You can deploy it in your environment and develop a business agnostic service and the UI which is using it. And we very much, what we really need, and usually this is the technical thing, that we are good in technology as EPAM, we are good in developing things. Where we really need the help is that you start using it. Thank you very much, and now you can give me some questions, and I open the page that is, and I don't see if you were chatting anything. I was just typing in hello.